Hi, welcome back to my video. It's been quite a while that I haven't demonstrated any of my work. Today, I would like to demonstrate how to apply the cluster analysis on the IPEDS data. And one of the applications of the cluster analysis is to select the peer institutions. Which means you select the colleges that are similar to a particular institution or college. This video is just a demonstration of what is possible, but both the clustering and the peer institution selections are evolving topics. There are still many progress can be made in both frontiers. Let's begin my demonstrations. The first thing we need to do is to select the data. So for this particular demonstration, I'm using the 2017 IPEDS data, and I select all the state, and I selected the public four-year institutions. If I so look at it, the sectors, we look at the sector and we select the one, and the sector one is a four-year public four-year institutions. And once done that, then we decide we need to select the majors or the variables. And for this particular one, we select the for enrollment and race data, IPEDS for enrollment race data, and we filter for the total and 2017. So we select the three variables. It's basically a grand total men, and the grand total and grand total woman. Then we click the button and we select the variables, those three variables. And after that, we'll refine the variables we select. In this particular one, we only interested in the undergraduate student. So what we did, we picked the two. We pick two all undergraduate, all under student. And that's where we have over here. We have since we have the men, we have a total, we have woman, so we have a undergraduate men, undergraduate woman, and undergraduate total. And then we select the full-time under. So we have to select the 22. That's a full-time undergraduate student. And that's we did over here, full-time undergraduate student. So for full-time undergraduate total, full-time undergraduate man, and the full-time undergraduate woman. And the last one we did is we did the 42. That's a part-time undergraduate. Part-time undergraduate student. So, and that's what we did over here. We select the 42, and for each variable they are part-time and under. So we have part-time under, and that is for the men, and part-time under for all total, and part-time under for woman. So we select those, so that's where we have all that. And after that, we select do all, and we go query our data. We build the queries, and we get the data. And so this is where we got the data. And once we get the data, we can select all of them and put it in a CSV file. And once we put in the CSV files, we can process them. We can read it in the process. We can read it in the CSV file and process them. Okay, process data to produce chart. Okay, this is Python. Okay, I did all this in the Python. I analyzed all this data in the Python programming language, and using some of the packages like the NumPy, Panda, sklearn, okay, and also the plot library. Okay. Okay, let's look at the summary result I have. Let me see. Okay. Okay, the first one is the result of a total undergraduate student. Okay, and what we did, we used what we call a shift mean clustering method. Okay. What shift mean cluster method is that they basically draw a interesting area and move the interest area around, okay, and they move that based on the density or based on the average location. So for example, if we start from here and we calculate the center, and the center will not be the center that I originally selected. So once we get a new center, we'll move that circle a little bit. Okay, then we calculate the center of all those points, and then we move slowly. Okay, so eventually we move to a dense area to a dense area, and then if it's move toward the other end, and it's become less, and it's going to move back. So eventually it just stabilized. Okay, and here's the result. Okay, let's just look at the one variables, just the total undergraduate total. Okay, undergraduate enrollment total, and we basically for the shift mean clustering, they basically determine for you how many cluster they're going to decide. They're going to decide the number of cluster for you, and it has something to do with estimate the original size of the circle, and then move it around, and then they decide how many cluster you're going to have. Okay, they start out by selecting a couple of position for their circle to start, and then eventually, of course, some of the circle may merge, and they become same clusters. Okay, in this particular case, with the 2017 data for the public four-year institutions, this is what we got. Okay, so those are the data points. Okay, so different institutions have different number of total undergraduate students, and all those are the institutions. And the vertical line, okay, or the bar chart, is the histogram. Okay, so we can see there are a lot of institutions have the size of about 1,500 to 2050. Okay, that's about their size. So there's a lot of institutions there. Okay, and there's a number of institutions. Okay, they all have different ones. Okay, and the little circle, the purple circle, represent the center of the clustering. Okay, so it's the center of the clustering calculated by the clustering algorithm. And the curve over here, the normal distribution curve I draw over here, is basically based on all the institutions inside of this cluster. Okay, say all the institutions fall under this green clusters. and we basically calculated their deviations, standard deviation, and also the standard deviation, and then we plot the curve. We plot the mean, and then there's standard deviation, and we draw the normal distribution curve. And over here, that's a second cluster for the blue. And again, we do the same thing. There's a center over the cluster, and that's how we draw the normal distribution. And of course, the distribution is not necessarily a normal distribution, but we just calculate it. So we say, well, okay, if it's based on the normal distribution, what the normal distribution would look like. Okay. And for the shift mean clustering, there's many different ways of not necessarily finding the center, but how they, well, you can say it does determine the final center. There's a different way of calculating a center or determining the centers. And one of the way is basically you draw a circle and you basically give every point in the circle the same weight. And the other one is actually you consider the center of the circle, and you assuming the distribution will be normal distributions. So you give it a more weight to the center, instead of those away from the centers. Okay, and in this particular case, we actually give both of them the same weight. We give all the points in the circle the same weight, and that's why it's not necessarily reflect the distribution. But okay, and the third cluster is over here. It's a red one, and the fourth cluster with the orange colors. Okay, so this is with one single variables. It's one single variables. And if we look at the second one, okay, we do a two variable clustering analysis. And this one is with one variable is the full-time undergraduate total, and the other is the part-time undergraduate total. Okay, and in this case, you can see we got about 12 clusters. Okay, and this is the same thing. We use the shift mean cluster analysis. And in this case, you can see the first cluster is here, the second cluster. Okay, we got a different cluster. And basically, you can see in general it makes sense, right? Like those are sort of separated, okay, and those are sort of separated by themselves, okay. And there's a many way of doing the peer analysis, and the idea, of course, is to select the similar institutions. And we have been seeing different way of doing things. For example, one method is basically just take the whole population, like in this case, let's say the total undergraduate enrollment, and basically just calculate a big curve, big normal distribution with all the point, okay, and come out with something like this. And then they can determine, of course, they can calculate the standard deviations, and they use that to measure how far away that the peer institution they selected. Okay, and the best thing about that is, well, if there's a natural break, okay, like over here, and that's really, I mean, the approach we took over here could give you a better estimate, a better selection mechanism, just because you can see in character those three are more similar. If you put the whole thing together, then you don't see this kind of distribution. You can see they are more like a overlap or several distributions. You don't see that. Okay. And also, some of them, for example, this is a head count, and some of them will also take the finance data and do the same thing. Okay. And then they combine the result. And one of the problems with that is you can see there are different majors. Okay. So by combining different majors, how do you know which one is more important, or which one should have a better weight, which one is should be given the priorities? Okay. And of course that the study they have made is basically they treat everything, they basically normalize everything to a single standard deviations. So they have one standard deviation, one data for the one variable for enrollment, one variable for the finance, and they all standardized. They all calculate their standard deviations, and they use that to measure how similar the institution is by using that calculate the standard deviations. Okay, and like what I point out, the problem with that is, well, one thing is they didn't see the features, and the other thing is, well, you use the overall standard deviation. Of course, you won't see these little features, and then you use that to combine the result, and that's in a way you can argue that in the overall picture it's sort of reasonable, but on the detail probably not good enough. Okay, and there are also people say using the total undergraduate, and they see how other institutions closer to that, and then they calculate the fraction of the full-time student and use a percentage to decide how close those institutions are. And the problem with this is, well, if you try to do that, 1%, how many headcount is represented by 1%? That percent would not be equal to, well, maybe 1% actually represent 5 people, where you originally you use 1 people for to determine every year how close the institutions are. And now 1% represent 5, so they are not weighted the same. And by using a cluster like this, you have a full-time undergraduate enrollment and you have a part-time undergraduate enrollment. They all head count. Okay, so they are compatibles. So when you measure the distance from one point to the other, they are measured the same direction, they are using the same unit on both directions. Okay, so in a way this will give you a better base for determining your peer analysis. Okay, that's a lot to talk about, but let's move ahead to see what I have. Okay, and on this one basically it's again this is a full-time undergraduate enrollment, and that's a part-time undergraduate enrollment, and basically those are the points. Okay, those are the same data point we see in the previous pictures, and what we did is we draw a distribution curve on top of that. Okay, so those are our distribution services, and of course if you move this you can actually look at it. Okay, you can see it look like this. Okay, so you can see like in this one, if we move it carefully, those are the distribution surface for those 3 points, and for those they are here. Okay, and there's one over here for the red clusters. Okay, so now let's sort of put it back, and you can also notice that this is in the street. Okay, this is two variables one. So it's a full-time undergraduate and part-time undergraduate total and the full-time undergraduate total. Okay, and then the next thing I did is okay, this is a different way of doing the cluster. Okay, this is what they call a hierarchical clustering method. And like I mentioned earlier, that clustering and also peer analysis are still evolving field, evolving topic. People still come out with different way of doing the clustering and different way of finding the peer analysis. And in this particular one, I'm using the what they call a hierarchic clustering method. And the one problem with this method you can see is, okay, for example, for this cluster, for the white cluster, they spread out a lot. You can see that. Even though, yes, we probably will agree, well, they probably similar in some way, okay, and those probably similar in one way, okay, but they kind of compare with those, they seem to be spread out quite a bit. And this is because of the algorithm you use to determine these clusters. Okay, this one is using what this is a hierarchic cluster, but inside the hierarchic cluster there's a different way of measuring distance, and especially distance between the clusters. And this particular one, they use what they call a ward, W-A-R-D, the ward method, linkage method. And in that case, that to determine the distance between clusters, they weight into the number of points inside that cluster. Okay, and that is why for those they are weighted less, so they are considered, they are separated from that. Well, there's a lot of points, okay, and they become much dense, because when they have a lot of points, they consider a big distance, even though they are seems to be very close to each other. Okay, so you can see with different clustering method, you come up with different clusters. And the idea, of course, is to find a method that match your needs, or that more describe your situations. For example, in our situations, we probably, if we want to determine a cluster, we probably don't like our cluster to be determined by the number of the point inside your cluster, because in our case we are trying to find the similarities in the way that how far away each institution they are distance from each others. So even though those are different institutions, and you probably determine, well, okay, those are similar institutions, and those are different institutions, okay, and you calculate distance between this one and the latter one, and compare with the distance between this one and the latter one. Okay, you can see they are similar distance, but for this particular method, the ward method, you can see the weight those heavier because there's more point, while those are weight much less. Okay, and so you don't want that in our case. In our case, we like to be distance is a distance, not weighted by the number of points inside your cluster. Okay. So those are one of the things you should consider when you pick the cluster method to use. And in our case, at least I think is a shift mean method is a better method to determine the clusters. Okay, just because they are not really determined by the number of points inside your cluster. Okay, and the next one, this is a 3D approach. Okay, and you can see all these points are in a plane, in one plane. And of course, this is because the three variables we select is full-time undergraduate total, and full-time, part-time undergraduate total, and the total undergraduate. And of course, you know the full-time plus the part-time will equal to the total. And that's why if you write a algebraic equation, say full-time plus part-time equal to the total, and you draw that, and that equation will basically determine the plane in the three-dimensional world. And that's why all these points are for under a plane inside a three-dimensional drawing. Okay. And one thing I'd like to point out here is, okay, and this is one of the things that's why it's important. Okay, if you look at over here, the white group actually has 3 points here. 2 of them are here, and 1 of them are sort of close to the red. Okay, and if we go back to our corresponding 2D, okay, this is basically the same full-time undergraduate total and the same part-time undergraduate total, but we didn't include the total, undergraduate total. So in this case, you can see those are the 2 white group, 2 white points, just like that one, just like those 2. Okay, they are exactly the same point, and you can verify that by looking at the numbers. Okay, okay, there's a 33K, there's a 18K, 18K. Okay, and you go back to that, you'll see there's your 18K. Okay. 18K, let's see, should I probably didn't look at the other one. Okay, there's a 17K, 15K. Okay, so you come back to here, that's your 17K, 15K, that's your 18K. Okay, and in the 3D, you can see they include another point, that's 3727, right? 3727. And if you come back to here, that's your 2710. Okay, that's your 2710. You look at the second number and the third number, 2710, Y and the Z. Okay, 27 and 10, and that's what you have here. That's what you have here. And the reason in the 3D, this one is considered as a same group as that, those 2, is because, okay, if you think about this, the radius on this chart will represent the total. Okay, so you can see those have the same radius. Okay, so they are, for the total, if you consider the dimension of total, those points are very close to each other, and that's why they are considered in a group. Okay, and this again demonstrates my point that you are not trying to do it in a 2D and then you go look at another one, say, okay, how are we going to determine that point? You will put all the variables together and you let them to calculate the total distance, okay, and to determine a group. And that's how this is done. Okay, you can see, let me see if I can, if we look at the total, if we look from this way, okay, and you can see, if you look from this direction, those 3 are very close to each other. Isn't it? Okay, the total will be like that. Okay, so if you see on this axis and this axis, all those 3 points are in the same axis, right? They're close to that. Okay. Okay, so that's a lot to think about, but this is what I did so far. Okay, and I hope this provide you guys some insight on both the how to get the data and how to do some of the analysis with the data. Okay, thanks. See you next time.